In our last video, we talked about two-way frequency tables. You might remember this example where students took a survey of whether or not they played an instrument and played a sport. And we took that raw data and we put it in a two-way table so that we could see, hey, here's 75 students that do play an instrument and don't play a sport. And this works nicely for this particular survey. However, sometimes we want to represent the data a little bit differently because these numbers are specific to a survey that totaled 286 people. What if we wanted to talk about general trends that would work for a survey of 286 or 2,000 or 20,000 for that matter? We're going to introduce today the idea of two-way relative frequency tables because relative frequency tables will give us something that is relative to the total size of the survey right here. So it won't matter if the survey is 286 or 20,000, the numbers will still work. And we're going to do that by using percents. So if you see relative, two-way relative frequency table, that means these numbers aren't represented as raw data, they're represented as a percent of the grand total. So we are going to create a new table that uses these same numbers, but we're going to do a relative frequency table instead. Okay, so we're going to use an I for instrument, S for sport. We're going to do yes or no, just trying to speed things up here for when we do the table. All right, and now we can start doing our percents. So we're going to take these, and the way that we do our percent is by taking the total and placing it in the denominator of a fraction, and we're taking the number that we're comparing to that total and we're placing it in the numerator. So percents are this division right here. We're going to do that for every number here, and we're going to put it in the corresponding box in our new relative frequency table. So for this one, it's 64 out of 286. So that'll be 64 out of, or divided by, 286. 64 divided by 286 gives us 0.22. 0.22. We can write that either as a decimal, 0.22, or we could write that as a percent. 0.22 written as a percent would be 22%. It doesn't matter. They mean the same thing, so just choose one and be consistent with all of these. I'm going to stick with the decimal, as I prefer to work with those, but if you choose to do a percent, that's fine with me. All right, we need to do the same thing with all the rest of the numbers and fill out our table. So this next one will be 54 out of a total 286. So we're going to do 54 divided by 286. 54 divided by 286 gives us 0.19, rounding each of these, by the way. That would be 19% if you were writing it as a percent. Again, I'm going to write these all as a decimal. Okay, I'm going to speed up a little bit and not write these down. I'll just do the calculation. So 118 divided by 286 gives us 0.41. And these two should add up to that number. 0.22 plus 0.19 does add up to 0.41. If you're rounding, you might have a little bit of error or difference in those, so be careful with that. 75 divided by 286. 75 divided by 286 is 0.26. Next, we'll have 93 divided by 286. That's 0.33. 168 divided by 286 gives us 0.59. And again, double checking, those add up to 0.59. 139 divided by 286. 139 divided by 286 is 0.49. So these are the totals, our marginal frequencies. 147 divided by 286 gives us 0.51. And 286 divided by 286 gives us 1. Each of these, 0.49 and 0.51, should add up to 1. And 0.41 and 0.59 should add up to 1 as well. So again, we can double check our numbers that way. So this, written as a percent, means that 22% of the people should be in this category. So that doesn't matter whether it's 22% of 286 or 22% of 20,000, we can use this relative frequency table in either situation, so it allows us to have a little bit more flexibility. Thank you very much.